All right, welcome Algebra 2. We are going to be starting Chapter 4, which is on quadratic equations. 4.1 is on graphing quadratic functions. So this whole chapter is talking about quadratic equations, and we're going to be looking at the visual side of that first. So to get into it, this just gives you a little visual of what a quadratic equation might look like. These are called parabolas, and these are actually pictures or stroboscope pictures of projectiles or things that are just jumping through the air or things that are bouncing. And what you're going to notice is that the path of all these things, like the guy on the motorcycle or a ball bouncing, right? Or a long jumper, the long jumper's center of mass, or a hurdler, the hurdler's center of mass. No matter what is happening there, a projectile, if gravity is just acting on it, is going to form what we call here a parabola. And a way to describe a parabola is through an equation that is a quadratic equation. So if you want something to just think about as we start chapter 4, think about these types of images. Think about what you could do, in the real world that would form these types of shapes. And that's the kind of language, that's the kind of equation that we're going to be working with today. So our learning targets today are really going to be looking at these quadratic equations and learning how to graph them. So I know how to graph a quadratic equation in standard form using the axis of symmetry and also finding the vertex. As always, through these videos, feel free to jump around in these videos, go a little bit quicker, pause them, rewind them, etc. The first thing that we want to talk about is a quadratic function. What is a quadratic function or a quadratic equation? It is a function that can be written in standard form, and standard form looks like this for a quadratic. It is y equals ax squared plus bx plus c, where a, b, and c could be any number at all. So as opposed to what we did in chapter 2 and 3, we just had equations that looked like mx plus b with an equation that has a degree of 1. But if we add this quadratic term in there, the ax squared, that's going to change the behavior of what the equation is doing. So this is the standard form of a quadratic. The graph of a quadratic function is also called a parabola. And that's what we saw in the first couple slides. It's that curved projectile type of motion that you're going to see when we start graphing these. Some more terminology for you to put down here. The axis of symmetry divides the parabola into mirror images and passes through the vertex. So basically what that's saying is that every parabola that we have is symmetrical. And there is this vertical line here right down the middle that we put a fancy name to. That's called the axis of symmetry, meaning the left-hand side of a parabola is equal to the right-hand side of the parabola. In other words, if you went outside right now and you just threw a ball up in the air, it would take a certain amount of time to reach the highest point. It would take the exact same amount of time to get back to your hand. Basically, it's going to be symmetrical. The second thing that we're going to look at or talk about for terms is the vertex. The vertex is the highest or the lowest point of a parabola. All right, so whenever we look at in Algebra 2 about a new function, we always typically talk about what is the parent function. The parent function is the equation that's just the most basic thing you can possibly graph here with no extra parameters involved in the equation. So what we want to do is just graph or look at y equals x squared. And it's already graphed here for you. Y equals x squared just looks like a parabola, as you can see in this little graph here. The first thing in this parent function is where is the axis of symmetry here? Where is the line that divides this? And we could look at this right here and say, okay, it's right down the middle right here. So when we don't add anything, The axis of symmetry is right down the middle, right at x equals 0. And where is the vertex of this parent function? Well, the vertex is going to be right here. In this case, it's the lowest point, and it's at 0, 0. So here's what we're talking about when we're talking about vertex, and here's what we're talking about when we're talking about the axis of symmetry, basically that middle line.